Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another episode where we talk about supplementary practice for Unit 2.3 this time, Newton's laws. So hopefully by now you should know that there are three Newton's laws. The first one is called the law of inertia, which means that an object that is moving does not want to stop unless acted upon by external force. An object that is stopping does not want to move unless acted upon by an external force. The second law is force equals mass times acceleration, or acceleration equals force over mass. And the third law is for every action, there's an equal and opposite reaction. Okay, let's go. We're trying to keep those under 15 minutes. If you are finding these a little bit difficult, go back and watch the original video where I explained the lesson. So this is not an explanation video. This is more about doing questions. Please make sure that you pause the video, answer the questions, and then check your answers with me. As I said, if you feel like they're a bit difficult, go back and watch the video lesson first before actually attempting the questions. Okay, let's go. So here is a bunch of questions that we have to answer. What is Newton's second law? So we've already answered that. So it's equals force times mass times acceleration, or acceleration equals force over mass. What is the equation? What equation allows you to calculate the force acting on an object? We've already answered that one. So it's force equals mass times acceleration. Or if you prefer, I can write it out so there's no confusion. Multiplied by acceleration. Okay, what is the net force acting on a 2 kilogram skateboard accelerating at 2 meters per second? Well, we know what the force is, so it's 2. F equals, no, we don't know what the force is. That's what we're trying to find out. So force, we don't know. We know what the mass is. The mass equals 2 kilograms. And the acceleration equals 2 meters per second squared. And we know that force equals mass times acceleration. So it's going to be 2 multiplied by 2, or 4 newtons. Easy peasy. That's the answer. Okay. And finally, if the mass of a skateboard is doubled, what happens to the net force? If the mass is doubled, what happens to the net force? Well, it's going to halve. Okay, so, but how do we know that? Well, let's see. Let's take the example we did before. Force equals mass multiplied by acceleration. And if we keep the force exactly the same as they told us, now the mass is going to, what happens to the acceleration of the skateboard? The mass is doubled. So the mass is no longer 2 kilograms, but it's 4 kilograms. Oops, 4 kilograms. Then what is the acceleration? Then the acceleration equals 1, clearly. So obviously, if mass is doubled, the acceleration will be halved. The acceleration will be halved. And this kind of makes sense. Think about it. If you're kicking a ball, a light ball, with a certain force, like as hard as you can, if you kick a light ball, you're going to accelerate it really quickly. However, if you try and kick a ball that is heavy, you're not going to accelerate it as much because it's heavier, because it has a bigger mass. And this is what we're talking about here. So if you double the mass, you're going to have half the acceleration. Okay, let's move on. What is Newton's laws of motion? 2a says identify a dog. A dog pulls on his leash with a 10 Newton force to the left. Identify the reaction force. So this here is about Newton's third law. Okay, if a dog, here is, I'm going to try to attempt to draw a dog. It's terrible, isn't it? Right, so 10 Newtons to the left. What's going to be the reaction force? The reaction force is going to be equal and opposite, so it's 10 Newtons to the right. To the right. Remember, Newton's third law says for every action there is an equal and opposite reaction. So it's equal in size, it's 10 Newtons, and it's to the right. Answer all three. Using all three Newton's laws, explain how objects react to forces. So what they want you to do here is just simply write the laws of motion. So the first one is law of inertia. inertia, also known as law of stubbornness. So an object doesn't want to change what it's doing. Does not want to change what it's doing unless acted upon by an, oh, this is going to take ages, external force. I tell you what, I'll use some magic to try and skip forward and see if we can do the next two just like that. Oh, there we go. Just like that. Magic. So now we've got all three. So the first one says, law of inertia, an object does not want to change what it's doing. If it's moving, it wants to continue moving. If it's sitting, it wants to continue sitting, unless acted upon by external force, unless forced to do so by something externally. The next one says force equals mass times acceleration, or acceleration equals force over mass. And the third one is for every action there is an equal and opposite reaction. Okay, here we go. Newton's laws of motion. Newton's second law of motion describes the relationship among force, mass, and acceleration. Write the equation. So time and time again you'll see this, and one way of writing this is by doing that. Acceleration. Oh god, this is getting a little bit trickier for me to write on. Equals what? Equals net force all over mass. Okay, acceleration equals net force over mass. Once again, this is the triangle, if you prefer the triangle, because then you can actually work out the different ones. Oh, mass, acceleration. How does diagram to the right illustrate Newton's third law? Well, as you can see, there is an action force and a reaction force from the ball. So Newton's third law says for every action there is an equal and opposite reaction. So what happens here is that the foot is exerting a force on the ball, and equally the ball is exerting a force that is equal and opposite in strength on the foot. Okay, so that's what's happening. So let's say the foot is exerting a force of 10 newtons, then the ball will be exerting a force of 10 newtons in the opposite direction on the foot. So that's all you have to say there, is that there's an equal and opposite force. For every action there is an equal and opposite reaction. So if the foot is exerting a force on the ball, then the ball is exerting an equal force on the foot. Let's have a look here. If the statement is true, write true. If the statement is false, change the underlined words or words to make the statement true. If you increase the force on an object, the acceleration increases. If you increase the force, the acceleration increases. Yes, true. Think of the formula, okay? Force equals mass times acceleration. So if I increase the force, I will increase the acceleration. Makes sense? So that is true. Next one. If you increase the mass of an object, the acceleration decreases. If you increase the mass, the acceleration decreases. Well, it's not worded properly, because do we keep the force the same? So assuming we keep the force the same, let's see. Force, let's say the force equals 4 newtons. The mass equals 2 kilograms. Then the acceleration is going to be 2 meters per second squared. That's just an example, yeah? If you increase the mass of the object, so it goes from 2 to 4 kilograms, and we keep the force exactly the same, okay, then the acceleration will decrease to maintain the force. So if you increase the mass of an object, the acceleration decreases. True. As long as the force is kept the same, then it's true. Number 5 says, to accelerate a 3 kilogram skateboard at 9 meters per second squared, a force of 3 newtons is needed. once again, force equals mass times acceleration, so it's 3 kilograms multiplied by 9, which is 27. False. False. Because it's not 3 that we need 27 newtons. And finally, number 6, oh no, not finally, the amount of inertia an object has depends on its speed. No, it depends on its mass. Depends on its mass. The more mass you have, the more inertia you have. Write the definition for the terms below. Inertia. So this is an object's resistance to change in motion. And as we described before, we said an object with more mass will have more resistance to change in motion than an object with less mass. How are we doing for time? 11 minutes, not too bad. Let's see if we can answer those ones. Once again, so this is modified true or false. So if the statement is true, write true. If the statement is false, change the underlined word or words to make the statement true. Please make sure you pause the video, answer the questions, and then check your answers. Okay, number 1 says, Newton's first law of motion states that an object will not experience a change in motion unless acted upon by a balanced force. No, that is false. Not a balanced force, but an unbalanced force, which means an external force. If they are balanced, it won't make a change. So it is unbalanced, the answer here. To increase acceleration of an object, you reduce its mass or increase the force applied. Yes, if it has less mass, or if you increase the force, then it will accelerate more. Newton's third law states that if one object exerts a force on another object, then the second object exerts a force of equal strength in the same direction. No, equal and opposite. Opposite. Number 4 says, what is the resistance to change in motion? Called stasis. No, it's not. It's called inertia. Okay, so that's false as well. Action and reaction forces acting in opposite directions do cancel out because they act on different objects. Do not cancel out because they act on different objects. So if they did act on the same object, they would cancel out. But since they act on different objects, they don't cancel out. And it's like the example we saw before with the foot and the ball. The foot acts on the ball, but the ball acts on the foot, so they don't cancel out. So false. They don't. Number 6, if you lean against the wall pushes back on you with a weaker force. Equal. Once again, that's a false. It has to be equal and opposite, so with not a weaker force, but an equal force. Newton's third law. Number 7, Newton's second law of motion states that an object's acceleration depends on its what? On its mass and the net force acting on it. Acceleration is measured in meters per second squared. Force is measured in units called newtons. And the smaller the mass of an object, the what its inertia, the smaller its inertia. Remember, bigger mass, bigger inertia. Okay. Anyway, hopefully that's clear. See you in the next one.